Okay, let's continue on with vectors. In the first video, we basically described vectors and described how to write or how to denote vectors. And I said the two methods that we're going to use the most are the IJ and then the magnitude direction. So let me just give an example of that, and now we're going to learn how to convert back and forth between these two different methods of writing vectors. I want to give a pretty straightforward example of a vector written in the IJ form. So here we have vector V. I'm going to call 3i plus 4j. Now you recall, that means when I get ready to plot this vector on a graph, I'm going to go 3 in the x direction and then 4 in the y direction. But my goal really is ultimately to take this vector v and to rewrite it and to express the vector in terms of the magnitude, I can't spell, the magnitude and direction of the vector. So this is the other main way that we denote or describe a vector, by giving its magnitude and direction. In this case, the magnitude is denoted by these sort of double vertical bars with the name of the vector inside and then an angle theta. So let's graph this vector, and by graphing it, I will just quickly show you how we come up with a way to convert an IJ vector into magnitude and direction. And what we're going to do, as I show you this, is going to be something you've really seen before, because it really involves some basic trig functions that we have learned a while ago. So here's like x3. Here's like y4. So if I want to draw this vector from my IJ coordinates information, 3x, 4j, which is a point about right here. Now I'm going to try and draw a straight line from my origin to that point. So there's my vector v. Now I want to take this vector v and change it and describe it using the idea of a magnitude and direction. So like I described last class, the magnitude of a vector, in this case, when we graph a vector, it's like the length. So I could say the length of this vector or this line is my magnitude, and then the direction would be this angle. So really, in order to convert this IJ vector into a vector described by magnitude and direction, if I can figure out some way to determine the length of this line, and if I can figure out a way to determine the measure of this angle, then I would be able to write the vector in terms of magnitude and direction. And we can do that pretty easily by just thinking back to some of our basic trig functions. What I'm going to do is I'm going to sort of draw a dashed line here to indicate I've sort of created a right triangle. Obviously, my vector here is like the hypotenuse of my triangle, and this dashed line is one of the legs, and then along the bottom, the x-axis is the other leg. Now, in a generic sense, just to sort of make it clear, anytime we have a vector drawn like this distance we can call y, right? This is the y distance of my vector, and obviously this is the x distance of my vector. If I'm trying to find the length of the hypotenuse, well, we've done this before. We go back to our very well-known and oftentimes used Pythagorean formula, right? Which says for a right triangle, the length of the hypotenuse the Pythagorean formula tells us how to find the length of hypotenuse based upon the length of the legs of the triangle. So for our case, just to make it easy to write, this magnitude, if we call this vector v, is simply the square root of the sum of the squares of the legs. All right, this is Pythagorean formula. We've done this many times. The length of this hypotenuse is, you take the one leg and you square it, you take the other leg and you square it, and you take the square root of that whole thing, and there you go. So really, in some sense, let me write this like this, although this is not really very, let me do it like this. To really get the magnitude, when you're given a vector in ij, to get the magnitude, it's like you take what I'll call the I part and you square it, and then you take the j part and you square that, and you add them together, and then you take the square root of the whole thing, and that gives you your magnitude, or your length, if you want to think of it in terms of this graph, the length of that line. So for our specific problem, the I part of our vector v is 3 squared, plus the j part, or the y part of our vector v is 4 squared. So this is 9 plus 16, which is square root of 25. So we've determined now that the length of vector v, or the magnitude, is 5. I could even go up here and just say, as a matter of fact, maybe some of you knew that right away because I chose to have a 3, 4, 5 triangle, just to make the numbers easy. So now we've taken this vector and we figured out the magnitude of the length, but we also need to figure out the direction. We need to figure out what this angle theta is. Now if we think back to trig functions, sine, cosine, tangent, we may be having a little emergency announcement for Ivy Tech here.
This is a test of the emergency notification
I'll wait till this is over.
This is only a test. This is a test of the emergency notification system. This is only a test. This is a test of the emergency notification system.
Okay, I'm still here.
This is only a test.
Hopefully it just goes on 3 times.
This is a test of the emergency notification system. This is only a test.
Actually, I think it's the first Saturday of the month at 11 o'clock, so they do this test.
This is a test of the emergency notification system. This is only a test.
Hopefully, they don't do it too many times.
This is a test of the emergency notification system. This is only a test.
Okay, I hope they're done now.
This is a test of the emergency notification system. This is only a test.
Wow, I guess they're not done. I don't know how many times they repeat this. Okay, so now we were back to this problem of this vector v. We were given the ij form of it. We're trying to figure out how to convert it to direction or magnitude and direction. We've got the magnitude of the length. Now we were talking about how to find this angle, theta, which will give us the direction. And I was going to say, let's think about trig functions. If we think about this angle, and we think about sine, cosine, theta, we know x and we know y. According to theta, x would be the sort of like the adjacent side. Y would be the opposite side. And if you remember from our trig definitions, the tangent of the angle theta, therefore, would be y over x. Now, if we want to actually solve for theta, if we go back to what we studied a little bit ago, if we take the inverse tangent of both sides, you end up with theta would be the inverse tangent of y over x. So this is a little formula we can use if we're ever given a vector in ij. If we want to find the angle, the direction of that vector, we simply take y over x. And once again, the y is like the j part, and the x will be like the I part. So in your mind, you really got to realize that when you see a vector written as an I and j, it's really x and y. So for our problem, y is 4, x was 3. So now we're going to grab our calculators. Let's make sure we're in degree mode. And I'm warning you now, in the future with some of these problems, you remember the special constraint about inverse trig functions? Remember inverse tangent? The answer is always going to be, the angle is always going to be between minus 90 and 90. Well, you'll see in a minute that that becomes important. As a matter of fact, I'm going to strongly suggest every time you do a problem like this, that you start out by drawing a graph, because that's going to make sure that when you do things like the inverse tangent, you don't get confused and give the wrong angle. So let me grab my calculator. 4 divided by 3 equals 1.33333. Now if I take the, oops, I'm in radian mode. See, I wasn't paying attention. Let me get in degree mode. So 4 divided by 3 equals, I take the inverse tangent, and it says 53.1 degrees. Which I look at my graph, that looks reasonable. 90 is straight up, 45 is halfway. Looks like it must be a little past halfway. So in summary, we started out with the angle V, written in ij form. And by using these two formulas, the first one, here's the formula to get the magnitude. And once again, when you see x and y here, think of the I part and the j part. And then the second formula tells us how to figure out the angle or the direction. And once again, you see x and y here, just think I part, j part. So when we do a problem like that, we realize that the magnitude for this vector ended up being 5, and the direction ended up being 53.1 degrees. So let's do one more problem where we convert from I to j. And we'll have a little bit of a twist, and I'll tell you in advance that the key is going to be when you get ready to figure out your direction or your angle, you have to sort of think to what's going on. And my advice to you is the best way to avoid mistakes is to actually draw the vector on a graph when you first start. So let's say we have a vector u, and I'm going to say the vector u is minus 3I plus j. So if you wonder what the x and the y part is, we'd say the x part is minus 3. The y part, I don't see a number there. Well, if you don't see a number there, there's really the number 1 there, right? So the j part would be 1. So we've got a vector x minus 3 and y 1. We're going to plot that in a minute, but the point of this problem is we want to convert that and know what that vector would be in terms of magnitude and direction. So I strongly encourage you and suggest that you it only takes about 30 seconds, just do a quick sketch of your original vector, because down the road it's going to keep you from making mistakes. So minus 3, 1. There's my vector. Looks like it's sort of in the second quadrant. That's going to become important in a few minutes. So we have these two equations. The magnitude equation is the square root of the x part squared plus y squared, or you can think of this as the I part squared and the j part squared. So for us, minus 3 squared is my I part, plus 1 squared is the j part. Looks like this is 9 plus 1. Square root of 10, and just so you know, when we're doing vectors, a lot of times they like you to go ahead and just give the number as a decimal. You usually round it to the 10th place. So I'm just going to go ahead and take the square root. Leaving it as square root of 10 is not wrong, but it's pretty common to convert this into a decimal. So there's the length. So basically, if I call this vector u, I could say the length was around 3.2. And now the formula for the angle or the direction is the inverse tangent of y over x, where y is the j part, x is the I part. So the j part is 1. The x part is negative 3. So I grab my calculator. So 1 divided by negative 3. Then I'm going to take the inverse tangent, make sure I'm in the degree mode. And here's what you get. Negative 18.4 degrees. Now this is why I strongly encourage you to always draw a graph when you're trying to do these vector kinds of problems. if you just blindly gave this as your answer, it would be wrong. Where is the angle of negative 18.4? Maybe I think negative 18.4 is right about there someplace. But notice my angle for this vector u is right there. So actually what I do sometimes when I do this calculation, I put a little theta with a tick mark because I'm not for sure until I work it out whether this is actually my theta or in this case it's like a reference angle. And that's the whole key here. Once again, because we're taking inverse trig functions, in this case inverse tangent, you've got to think what you're doing. Because your calculator and any kind of inverse tangent function, the angle is always going to be between minus 90 and 90. Obviously, the angle for this vector is larger than 90. But the inverse tangent function cannot give me an answer larger than 90. So you have to be smart about this and realize what I have here is the reference angle, which means I go here and I know that angle right there is actually 18.4. Remember, reference angles mean the distance from your line, closest distance to the x-axis. So really, the angle for my vector is you would take 180 degrees and you subtract the 18.4 degrees, and then the angle for this vector u, 180 minus 18.4 is 161.6 degrees. And that sort of makes sense. We know all the way across would be 180. We're a little bit short of that. That looks reasonable. So for vector u, the magnitude is 3.2. The angle, which I could have written up here, is 161.6 degrees. All right, so that's how, when you're given a vector in the IJ form, how you can convert the vector into magnitude and direction. Now I'm going to go ahead and create another video, and the next video is going to go the opposite way. The next video is going to say, okay, if I'm given a vector in magnitude and direction, how can I convert it into an IJ vector? And we'll talk about that in the next video.